LTspice is a freeware computer software implementing a SPICE electronic circuit simulator. It is produced by a semiconductor manufacturer Linear Technology, now part of Analog Devices. It is used in-house at Linear Technology for IC design. It is the most widely distributed and used SPICE program in the industry. You can download LTspice legally and for free on this web page of the previously mentioned company Analog Devices by simply clicking the download link below. Now we head up to the introduction of basic components of LTspice. Let's start with the icons provided by the program. We click the new schematic icon and obtain a new window with gray area, which means we are ready to build our circuit. Next on, we can see the control panel icon, run and stop, zoom management, tracing and plotting, Windows management, current copy, printing, and drawing section, which is very important for us. In this section we can find the basic components of our circuit. By clicking the picture we can add them on the circuit, but we'll do it in just a moment. Now we will focus on the shortcuts. First, and the most important one, is F1. It opens LTspice Help, which is basically the manual. If everything else fails, read the manual. By clicking F2, we obtain the component symbol window. Here you can look up all the components you wish to add to your circuit. F3 is a shortcut for a wire, which can be drawn vertically or horizontally and making perpendicular lines, which are the wires of our desired circuit. R is for resistor, C is for capacitor, L gives us coil, G gives us ground. By clicking delete we obtain the scissors, which will allow us to cut not important and unwished parts of our circuit. Left mouse button pins the component to our board, and right mouse button gives us back the cursor to manipulate of our circuit or the panel. And now some useful comments. By clicking T we obtain a comment window, and by clicking S we obtain SPICE directive window. As you could see, this is exactly the same window, and here we change whether we want SPICE directive or comment. They both can be also found here in Edit, Panel, SPICE directives or text. While holding a component, we can click Ctrl plus R to rotate it and Ctrl plus E to mirror it. Both of these can be found in here. So now let's move to some simulation commands. OP stands for an operating point analysis, which will provide a DC analysis of the circuit, and results will appear in a dialog box. Now by clicking enter, we obtain our instructions and we can manipulate whether we want to put it on our scheme board. Okay, so now let's go to some analysis commands. The first one is tran, which we use to perform a nonlinear transient analysis. It is a time domain analysis. To start a new line in the dialog box, we simply click Ctrl plus M. The next analysis type is AC analysis, which is done. The next one is .AC, which performs a small signal AC analysis, which is linearized about the DC operating point. As we can see, we choose whether it is octagonal, decimal or linear, number of steps, starting frequency and ending frequency. The last one is .DC, which performs a DC source sweep analysis. We type the name of our voltage source, starting voltage, the voltage which we want to stop, and the step of increment. And by clicking enter we control this whole set of instructions and we attach them to a desired place on our scheme. So now let's solve this exemplary task. We need to find the value of RB1 resistor while the collector current is 1.5 mA. So how to do it? First, we start with putting the informations provided us in the script. So by right clicking, I am able to change the value for VCC. I set 15. I have already changed the names of the resistors and the voltage source, and all of the circuits I have created previously using the tools presented before. RC value 1.5 kilo. And now we want to somehow manage the model and the unknown values. So by right clicking and putting in this kind of brackets R, we set it as our new variable. And we know that both of these resistors sum up to 150 kilo ohms, and we are interested in this one. So the second one, also in this kind of brackets, we will set as 150 kilo minus R. And now let's focus on the model. We open by clicking S, SPICE directive, and right now we need to type. .model function will allow us to create our own new model. We named it Bob, type npn, and in the brackets we set our desired values. By clicking OK, we can see that this text differs in the color from the command because this is an instruction, so we can attach it next to our circuit. So what we are left with is to change the name of the model into the one we called in the function. And right now the only thing left is the unknown parameter R. So how do we deal with that? To do that, we'll use the step function. We type the step function, type of our stepping, which is parameter, the name of it, which is R, beginning value, ending value, and the step, which is 1 kilo. Now what we lack is our DC operating point analysis, which we will add in a moment by clicking S, typing OP, and now here we have everything to start. So let's run the analysis. We received the draft and we are interested in the collector current. So we'll click on the RC resistor, and right now we see the draft. How does the current change? We're interested in the value of 1.5 milliamp. So by clicking IRC, we obtain a tracker which we can manipulate through our trace to find the desired value. In here below we can see a text box that shows us horizontal and vertical value. We want 1.5 milliampere, so our vertical value needs to be 1.5. It's right here, and we can see that such value in this model, in this configuration, will be obtained when the RB1 resistor is 143 kilo ohms. So we are given a task to find the gain for the given circuit for midband frequencies using small signal analysis. So as we remember, to do the small signal analysis we will use AC function, and we need to type the AC decade type, which will be 10 steps per decade from 300 to 300 kilohertz. And we also need to change our voltage source by adding AC amplitude equal to 1. And what we can add to easy for us the task is labeling for the wires. So here we can label it in, and you need to attach it to the wire, and here we can label out and attach it to the wire. So now let's run the analysis. And by right clicking add traces, we can choose what kind of traces do we want. We can choose voltage, current, or frequency. We are interested in the initial gain, so we'll choose voltage on the out, which we created by labeling, because otherwise you would have to choose the specific nodes, and divided by the input voltage. So we obtain such a trace, and this represents our gain. And by right clicking on the axis you can change whether it's linear, logarithmic, decibel, or types from both Nyquist and Cartesian. and it is simply how to perform the AC signal analysis. So now let's head to the summary. We recommend LTspice for beginning engineers who want to create their circuits because the ability of drawing allows them to visualize better what they are dealing with. However, after some time, you need to be able to know your circuit just from the netlist. So after that, we recommend PSPICE, which is much more skillful and powerful program than LTspice. So if you want to start your activity with creating your own circuits, we recommend strongly LTspice, but in some time you need to switch to PSPICE because it gives you more abilities and allows you to create more advanced circuits. To sum up, LTspice is for beginners and PSPICE is for pro and macho engineers. Thank you for your attention.